Good morning, Bronx Arts team. I'm just going to go through these slides really quickly for those of you that did not get a chance to join me this morning. And even for those that did join me this morning, I just want to make sure that we go through the slides quickly. And if you have any questions, please feel free to reach out to me at sjones@bronxarts.net. Text me, email me, whatever you need to do. I am available. All right, so happy Monday. Today is Monday, March the 30th, and this is our assignment for today. Today's agenda, the first thing is activity 13.1, taken again directly from your workbook. We'll talk about that shortly. Quick vocabulary review. You're going to watch a video. We're going to talk a little bit more about maths. We're going to review the SIR model and then your exit ticket. Activity 13.1, the question is, does mass stay the same or change when we make gloop? What is gloop? Gloop is basically corn flour, slime, and it's easy to make and fun to experiment with. So gloop is another word for slime. Vocabulary review. The words are density, weight, and mass. Density is the amount of compactness of a substance. Weight is the heaviness of a person or thing. And mass is the measure of the amount in an object. Weight and mass are completely different. They are not the same thing. The weight is how heavy or light an item is, and the mass is the amount. So if I say, oh, I'm using a teaspoon of sugar, the amount of the sugar is the mass. Now we can weigh a teaspoon of sugar to see how heavy it is, but the two items are completely different. Mass is how much space that sugar takes up. That is your mass, and it's completely different from weight and density. Our gloop and our prediction for today. So please just jot down the answer to this question. Do you think the mass will change when you make gloop? And explain why. So take about 30 seconds to try to answer that question. We're looking at the young man holding some gloop in his hand. Do you think the mass will change when you make gloop? So you start off with the reactant. You have some substances that you're going to put together. And then you're going to have the end product, which is your slime or your gloop. Did the mass change? Now we're going to watch a video on how to make gloop.
Hey everybody, today we're going to do this neat activity where you can take some simple stuff that you might have at home and use it to make slime. You don't need much, you just need some stuff called borax, which you can get at the store, glue that you might have around the house, some water, and popsicle stick. Now let's get started. First thing you need is just a tablespoon of water, a quarter teaspoon of borax. I'm going to stir that with a popsicle stick until you get as much to dissolve as you can get. So that's your borax solution. So once that's done, you want to make a solution from glue. You need another tablespoon of water and a tablespoon of glue. And now we're just going to add the borax solution to the glue solution and see what happens. You can see it begins to change until you have this really kind of cool glob. There's your slime. So now you want to try to take it off the popsicle stick and squeeze it to get any kind of extra liquid out of it. There's your slime. It's not even that sticky. You know, when I was stirring the borax solution into the glue solution and you got this cool sort of semi-solid blob, you know, there's chemistry involved in there. The glue in the glue and water solution is made up of these long, stringy molecules known as polymers, and they kind of slide past each other, you know, as a liquid. But when you add the borax and water solution, the borate ion hooks those long polymer molecules together and makes it kind of more solid. And that's what makes the slime that we get. So there you have it. You can make this really cool slime out of just simple ingredients. And there's some cool chemistry in there. That's really neat. There's another thing you can do if you want. You could take 1 drop of food coloring and add it to your borax solution, and then add it to the blue solution and stir. So your slime would be colored. It's pretty fun. So you guys have a good time experimenting and making slime with chemistry.
Very good. So you guys got to see the video on how to make slime. Let's talk a little bit more about mass and what that looks like. What happens to mass when objects are mixed? The law implies that mass can neither be created nor destroyed, although it may be rearranged in space or the entities associated with it may be changed in form. For example, in chemical reactions, you guys are familiar with chemical reactions, the mass of the chemical components before the reaction is equal to the mass of the components after the reaction. What is it called when you have components before a chemical reaction? What are those substances called? They're called reactants, correct. And what is the substances called after the reaction? If you said product, that is correct. So what this is saying to you is your mass for your reactants is equivalent or equal to the mass of the products. So if I'm starting off with 2 substances, the total mass of those 2 substances before I even mix them are equal to the total mass of my end product after they're mixed. So I combine the 2 substances. If I have 2 tablespoons of sugar and 1 tablespoon of water, that is 3 tablespoons in total. My product or end result will still be the equivalent of that 2 tablespoons of sugar and that 1 tablespoon of water. They are equal. The mass does not change. Now we're going to talk about the SIR model. SIR, we know it's claim, evidence, and reasoning. SIR is the acronym for claim, evidence, reasoning. So hopefully you guys remember that. And what is it used for? It is used to state a claim and to support your claim. Very good. Let's just review it. The claim portion is the answer to the question in one complete sentence. The claim portion is the answer to your question in one complete sentence. Your evidence, you have to use at least 2 pieces of evidence from the text or image that you used to make a claim. So you always look for evidence to support. So if I say, Akira is passing science class. Okay, so what is my claim? Or actually, if the question is Akira passing science class? And your claim would be, yes, Akira is passing science class. What evidence do I have to support that? Akira comes to her chat rooms. Akira turns in all her assignments on time. Akira is passing all of her exams. You only needed 2 pieces. So those 2 pieces that I would use, which is the strongest portions of evidence, is Akira hands in her work on time and Akira is passing all of her exams. Now I can do my reasoning. And my reasoning explains or puts together your claim and your evidence. So for my reasoning portion, I would say, due to the fact that, and I would go to my evidence, due to the fact that Akira is turning her assignments in on time and she's passing all of her exams, I can conclude, and I go back to my claim, that yes, Akira is passing science class. That would be my reasoning. So your reasoning portion is putting that claim and evidence together during your conclusion. Can't leave until you finish an exit ticket. So therefore, what I need you guys to do is just take a little piece of paper and you're going to jot down the answer to this question. What is mass? I will make sure there's some space at the end of your Google Doc so that you can type your answer in there. And I will see you guys in the chat room tomorrow. Have a great day.